Hello guys, so today in this video we are going to talk about a very interesting topic and a chapter of the class 11th math, and that is probability, as you can see on the board. Now in this video we are going to cover so many of topics which I had written here. So now let us see them and then we will start our lecture towards this basic chapter. So now the topic which are to be covered here, that is, we can see here is given the introduction. So you will get all the basic points related to this chapter here, means introductive part will be definitely clear to you. Now in the next one, that is the random experiment. In this we will discuss what actually random experiment is, and in this it is being consist of outcome and sample space. So here we will also move towards this and discuss this in very much interesting way. So now what I had told you, these 2 points are being consist of which exercise, that is exercise 16.1. Okay, so exercise 16.1 is on the basis of these two things. Means in the introduction part we will talk about probability, who had given the theory of the probability, what are the three main approaches to the probability. Now these two are being consisted in the exercise 16.1. Now in the second one, here is given events. So we will discuss events also in a very much interesting detailed. Here we will discuss about the occurrence of the event. So here, as we will discuss about event, then where actually this event is being presented or where event is being coming. Here we will discuss types of event. Okay, so there are several of the type of event which we will cover in this video only. Here is given the simple, compound, impossible and sure events for your learningness or understanding. Now algebra of events. Here we will talk about the complement, or we can say in the other ways we will also discuss about the mutually exclusive, or we will discuss about the exhaustive event over here. So we should see this in the super detail. Now the last point which we will cover in this chapter is axiomatic approach to probability. So all of this chapter is being based on this thing only. This is axiomatic approach to probability, and on this basis these things which we will cover here, this is comes under this, and this video lecture will be only on the basis of NCERT. So now let's start with the introduction part. So now let us discuss about the introduction part. So when we are started to go with introduction part of any topic, then we have to know actually that what is the meaning of the chapter. So the word meaning, the probability. You have also heard and also solved many of such questions related to probability in your last two classes. That is 9th and 10th. In that classes also you had gone through with the probability. So now firstly and the foremost thing which is, that is what actually probability is. Okay, so now here first question which is being arising, that is what is actually a probability. Okay, so probability. So probability is usually we get a relationship between the possibility of something to happen. So what we will write, possibility of something to happen. This is what we call as probability. Probability is something, means possibility of something to happen. Means in this case we are not be sure that what that thing will be going to be happen, but we are having two or more outcomes or the results that can be happen throughout this. So we should take some examples on the basis of this so that we can understand properly. So here we are taking some more interesting examples on the basis of this. The example which we are taking, that is of, we can say, a die. First example, a die. When we roll a die, then we are knowing that there are 6 numbers are being given on that. So we can say 1, 2, 3, 4, 5 and 6. These are the outcomes which we will get after rolling a die. But if I ask you a question that are you exactly knowing which of these will come? So that is no. Means it is uncertain that 1 can come, then 3 can also come, 6 can come, means any number can come and we cannot predict what will come here. Okay, so that is the example of possibility or the probability. Yes, in the day-to-day life, that is taking the example, that is the second one, that is of course of the rain. Okay, when we see the rain can be come, then we are having some probability like the 90% of the possibility that rain can come. In that also you are in your mind also 10% will be that rain cannot also come. Yes, so in these cases also we define this as a probability. Now see, this is also be useful for you, that is also a coin. For the coin, in the case of the coin, we are knowing the outcomes are head or tail. These are the two major outcomes which can come when we started to toss a coin. After that, we are also not predict it as this will come or tail will come. Okay, so in these cases also we can say. So in this we cannot predict and we are doing that possibility of something to happen. Means we can only give an idea that head can come or tail can come. But in the real manner we are not doing this so. So now we are going to talk about in the 9th and the 10th class which we had studied. Okay, so in these cases, in the 9th class what we had studied, that is the statistical approach. Statistical approach we had discussed. In the 9th class we are given with the data is given to us, the favorable outcomes are given to us, then we started to solve the questions and then we find the probability. But in the 10th class we gonna get an idea or the formula related to probability and on the basis of that we solved it. And that is known as classical. But they are having certain difficulties or we can say some drawbacks are also being presented in these two kind of the approaches regarding the probability. So for we can say stopping this or for developing a new idea. Okay, so idea I had told you firstly also that was axiomatic approach to probability. Okay, let me write it down here. Axiomatic approach to probability. This was an approach to probability which was given by a famous Russian mathematician in 1933 in his book Foundation of Probability. He had written a book Foundation of Probability where he given this axiomatic probability. Okay, axiomatical approach to probability. Here we had discussed this in the earlier classes. Now as we are being promoted or we can say come to next class, then we have to talk about this axiomatic approach to probability and this chapter is based on this. Okay, so now let us move toward the formula. Okay, here in the probability there are not a lots of formulas to be used. Okay, there can be some rules but not the formulas. There will be only a single formula. So let me write down here, that is number of favorable outcomes. Number of favorable outcomes upon total number of possible outcomes. Okay, number of favorable outcome upon total number of possible outcomes. This is the formula for the probability. Okay, for proving the formula, let us take some examples or otherwise some of you that knowing this formula. So number of favorable outcomes. here we are getting that suppose we had taken the example of coin. Okay, here we are given with head and tail. These are the two outcomes. These are the two results which we are knowing that these will become. Okay, now number of the favorable outcomes. So favorable, if an umpire toss a coin through me and you, then you are thinking the head should become. Then definitely I will thought that tail should come. Now when you are thinking the head should become, so head is one here in the two outcomes. So we will write you want one of these outcomes, and total number of outcomes is tail can also come, head is also come. So there is the 2. So we can say 1 upon 2. Means the probability of getting head is 1 upon 2 when the coin is in the air. But after reaching to the land, then we get that the result head can be there or tail can be there. So probability we get that 1 upon 2 for the head, or if we will find out for the tail, then I will think the tail should come, then tail is 1 in the number, and then all the possible outcomes are 2 and then 1 upon 2. This is also 1 upon 2. Now there is also a rule is being given that always there will be the probability of sum of all the probabilities should be 1, not more than 1 and nor less than 1. If we are having this, then we can say that it is right. Okay, so now let us proceed towards to the next thing, that is the random experiments. So now let us talk about the random experiments. So here, as we all are knowing in our day-to-day life, as we are knowing that there can be two type of experiments. Here we are talking about the two types of experiments can be there, or the probability can be there, we can say. So in the one case we are knowing the actual result without knowing the first things. We are knowing its result, what will happen if we will do these things. But in the second case, we are knowing what we have to do, but we are not knowing the actual results. So take an example to elaborate this statement. Okay. So now here the examples which I am taking over here, that in the first case we are knowing that we are knowing the result. Okay. So your teacher had been given a triangle to you. Now in this case you have to find out the angle of these three angles are unknown for you, and he had asked what is the sum of angle of these triangles, this triangle. Then you will definitely and directly say that this will be 180. In this case you are knowing the result but not knowing the first things. Okay, so this is known as the other probability method. But in this random experiment, in these cases it is usually as similar as probability. Taking an example of a coin. Okay, taking an example of a coin, what we are getting here is that we are knowing there are the two outcomes are being presented. There are two outcomes are being present, head and tail. Okay, head and tail are the two outcomes which are being presented over here. Then what we have to do here is, we are knowing that outcomes are two and we are given with a coin. Then what will happen, the result can be head, can be tail, means may or may not. Okay, in these cases when they are may or may not, then that experiment is known as random experiment, means rapid experiment we can say in our language. This is what we call random experiment. This one is the random experiment. This is not the random experiment. In this case we are knowing the result, and in this case we are not knowing the result. So I am giving you the two conditions. If these two conditions satisfy, then the given statement can be your random experiment. So write it down here. The first, it is given as that the if more than one outcome, more than one outcome, this is what we given with that. This is the first condition. Okay, so write down second condition and then see what actually this is. Second one is, in this case is no prediction. No prediction of result. And I'm telling you again and again, this is fully based on our NCERT book class 11. Now here is given if more than one outcome, means first condition is given, if there are more than one outcome, then only we can say it is a random experiment. But second should also be certified. Okay, second is no prediction of results. Okay, means result should not be predicted by you. Means you should not have to knowing the actual result. You should know the result, but that should be the possible result, not the actual result. Okay, now let us know and put it into the this given example of the coin, where I told you that this is a random experiment. If more than one outcome, okay, more than one outcome, then let us see head and tail. Head and tail, head can also come, tail can also come. So in this case there are the more than one outcomes, means there are the two outcomes. Okay, here is no prediction of result. Here we are not knowing the actual result. Here we are knowing head can come, tail can come, but not knowing the head will only come or tail will only come. So here in this case also we can say this is a random experiment. Now here we are given with two kind of things. First there is outcome. Second one, what we are knowing, that is the sample space. Sample, okay, sample space. Now what actually outcome is? Outcome, as we are knowing, it is the possible result of the random experiment. Okay, write it down in your words, and this is fully, I had told you that this is the right definition of the outcome, is the possible result of a random experiment is known as outcome. And for the sample space, it is being given a set of all the possible results of a random experiment. So here, as we are knowing that here is the head and tail can come. Okay, so what we will write in the outcome case, outcome can come head and tail, means this can be a possible result, not the actual result. Okay, in the sample space, set means not to be write in the different boxes, write in the same box as we are knowing. So we will write it head and tail. So what we get, the sample space, and we should use the curly braces over there where we should going to use that. So in this case we had done the random experiment fully using the outcome and the sample space, difference between them, each and everything cleared, and through this we can easily solve 16.1. But I will also make video on the 16.1, 2 and 3 respectively. Okay, and here what we had done clearly. Now I should erase it. So now let us talk about this event. So now from here we are going to do all the bases of the exercise 16.2 for this probability chapter. So now here we are given with the event. Okay, so what actually event is, as you can see on the board, any subset of event E. Okay, we can say event as E. Okay, we are representing event as E, sample space as S in our books also. So any subset of E of a sample space. Okay, so now let us see this in the detail with the taking an example. So now we are taking an example over here. Example as we are knowing here is that we are using for the die. Okay, a dice is being given to us, then we started to roll it, and after rolling what we get is that we are given with, what we should get is it is that we can get 1, 2, 3, 4, 5 and 6. Okay, this we can get from rolling a die. But here what we are seeing, that these are the 6 outcomes which we can get. But still we have to see that the subset of E of a sample space. Sample space, I had written this in the form of a sample space. Sample space represented as a S. Okay, Now what we will do here is 1, 2, 3, 4, 5, 6. Then as we can write it here that 1 is a subset of what? Subset of a sample space, and sample space is, we can say, S. Or we can say here is that we are using even numbers are being given to us. So for the even numbers, if we are writing that is 4 is a subset of all the even numbers present in the outcomes, possible outcomes of a die, then we are knowing there can be 2, 4, 6 respectively even number. So what we will get, 4 will be subset of S. Okay, so like this only we will resolve all the questions related to probability on the event part. Okay, now let us talk about the occurrence of event. Okay, occurrence of event. Here we are given with the occurrence of event. So here what we have to do is, I had given you some examples over above. In this case what we are getting, that we have to take an example here. So we are taking example of this die only because this is going to be a interesting one. Then we are knowing these are the 6 outcomes can become. Then we are taking that odd numbers. Odd numbers. In the respect to the odd number, we are knowing that can 3 be probability of, or the we can say occurrence of the event for this. So we can see why not, because 1, 3 and 5. Okay, 1, 3 and 5 we can say as a odd in the die, and throughout this we can get 3 subset of, we can say, odd numbers. Okay, odd numbers of the die. So like this only we had also discussed about the occurrence. And if we are knowing that the 2 is coming in the, we can say, odd number, so no. So we will write not occurred at all. Now let me raise it and we will discuss about the types of event. So there are usually 4 types of the events are given below. So let me write it down here is types of event. Types of events. We are knowing, I have told you the 4 types of the event here. So 4 type is, we can say, impossible event. Impossible event. We can say sure event. We can say simple event. And here we can say compound event. So I had told you impossible event, sure event, simple event and a compound event here. So let it be, should be evaluated and elaborated. So in the impossible event, what actually impossible event is? Where we are getting the 5 is being coming here. Okay, where we are getting 5 as a result. Okay, now let us take some examples. So let me take a single example. Throughout that I will clear your impossible, sure, simple, compound collectively. So now let me take an example of a die here. Die, we are knowing outcomes 1, 2, 3, 4, 5 and 6. These are the outcomes in the die. So now what we are going to do is, for the impossible part, so if the statement is being given as, we can say that if the outcome is the more than 6, if the outcome we can say less than 1, we can say the multiple, we can say multiple of 7 or more than 7 as below. So now here we are not getting any of these things which I had told you. So what we will use here is, means for more than 7 we can use 5. So this 5 sign will also be helpful in this chapter, as this was also helpful for us in the sets chapter. So now let us talk about the sure event. Sure event and impossible event, these are just opposite to each other. Okay, in the impossible event you are not getting a single kind of outcome, but in the sure event you are getting all outcomes. Okay, so now here what you are getting is, means all sample space you are getting. You are getting all sample space. whole sample space is being given to you, and throughout that you will solve each and everything. So means you are given with 1, 2, 3, 4, 5 and 6. So is that is a sure event for rolling a die? Then you will say that yes, it is a sure event, because we can say that the sure event is all about the sample space. Whole sample space is known as a sure event. So now impossible and the sure event are just opposite to each other. Okay, these are just opposite to each other. Now let us talk about simple and a compound event. In the simple event, by the name itself we are getting simple, like we can say 1. So in the elements here, in the way of a set, we are getting this 1, 2, 3, 4, 5, 6 are different elements of this single die. Okay, in the die 1, this is the different element. So what we are getting is, if we will write 1 is the subset of, we can say, rolling a die. If 2 is a subset of rolling a die, then they will known as this. But it should be moreover different from each other. Okay, means they should not be get collected as per the sure event, and if they are collected, we will say it is directly equal to sure event or compound event, means these are truly to be collected. Okay, when they are fully collected, okay, when they are fully collected, then they started to make this. So now this simple event and a compound event are just opposite to each other in these ways. So we had discussed about the types of event here, and with a very interesting example of a die. Now let us proceed to more parts. Now let us talk about the mutually exclusive and the exhaustive event here. So now in the mutually exclusive and the exhaustive event, these are also types, we can say, or in the different way in the class 11 only, these are being added here, and these are also truly important for the exercise 16.2, which we will also clear. Okay, so now mutually exclusive, this word here, we can say, by removing mutually we are getting exclusive, means exclusive we can say as a disjoint, means not present in that. So now here we are given with a very interesting thing, that is this, we can say, as a formula which we can use, that is where we are given with a event and a b event, and where if we will intersection it, then we are getting phi. Take an example so that we can understand it clearly. So now again we are taking the example of a die, and here what we are going to do is that here we are given with this event is being consist of a 7, 8, 9 or 10. Okay, here this event I am talking about B event. Here in the A event, what we are talking about simply 1, 2, 3, 4, 5, 6. Okay, so we are talking about this. So they are having the, we can say, we can say as a intersected, any digit is being intersected in that, then we are knowing that yes, only 5. Okay, means not a single digit is being, we can say, intersected in that, in the A probability and a B probability or the event. So we are getting here the 5. So means take a look over the Venn diagram. Venn diagram is like this. Okay, this is, we can say, A, this is B, and here they are, this part is known as A intersection B, as you are knowing, I think so. Okay, so A intersection B. But if we look over there after some time, if we are getting A alone, B alone, okay, we are getting A alone and B alone from each other, then what we will say, A intersection B will directly equal to 5. And this is what we had just proved over here. So we can say this is the mutually exclusive event. So in the exercise 6.2, you will also give, I had given you a basic idea related to that, but in that you will clear each and every questions related to that. exhaustive event. It contained everything. Okay. Now in this thing, in this case, you had gotten this. Okay. You got this. In the mutually exclusive part, you got this, but in the exhaustive event, you will get all the sample space. Okay, all the sample space will be given to you, and that will just inside the exhaustive event, and this event will simply. Okay, so now we are given with a event, and this event of the rolling a die, and if we are knowing that we had taken the another event as per this die, that is the 1 2 3 4 5 6, then also we will get the exhaustive event. So now we will morely talk about the another point, that is going to be axionomical approach to probability. Till now we had discussed about whatever we had discussed, that is being consist of axiomatic approach to probability. So now let us talk about that over here. So now here we are going to talk about the axiomatic approach to probability over here. So now what we are knowing is that axiomatic approach to probability is given by the A.N. Kolmogorov, a Russian mathematician in the 1933, in the book of the Foundation of Probability. In that he told about the axiomatic. Okay, and I had told you earlier also, there were some drawbacks which were present over there in the two approaches of the probability which we had discussed in the 9th and the 10th class, and that were the statistical and which we are knowing classical. In these, the drawbacks were they were not useful in the cases of the infinite outcomes, but this is being used for all the infinite outcomes which we are knowing over here. So now let us talk about this. So now he had told some rules which were related to this probability or the axiomatical approach come in the force. Here rules which are being given over here is that the probability of the omega, here this is not w, this is like a omega sign. Okay, omega for the nth outcome, and that will be greater or equal to 0, not less than to 0. Okay, so now taking an example, we will complete everything. Okay, so we are knowing or given with that 1 2 3 4 5 6 and so on towards the n. Okay, like this we are given with. Now as we are knowing that outcome is represented in the form of omega. Okay, omega sign is this. Okay, this is the omega sign, and this is omega 1, this is omega 2, omega 3, omega 4. I am not using the numbers in the place of like the omega 1. I am using, this is the term 1, term 2, 3, 4 and so on. And this is term number n. Okay, so now what we are getting, this is the probability for the omega for the n outcome, that will always be greater than or equal to 0, not less than. So take an example, if in the questions we are given with that we are given with omega for the n outcome, we are given with -3. Okay, we are given with -3. So now any question is being given to you, you should not solve it, because that is being told that the probability which is less than 0 I am getting. Okay, this is being highlighted here, that -3 means this minus should not be there. Okay, throughout that we can easily do that. Means what we get from this case, we get this. So now let us illustrate it. What we get here, 0 is the last point throughout which the probability can be there. Okay, so 0 is the last point from where it should be, we can say that the greater towards this probability for the omega for the n outcome, and omega n outcome probability can be 1, can be 0, between the 0 and 1, but not more than 1, not less than 0. And this is what we get from the above given first rule, Our first rule is being just equal to the second rule if we will discuss it. Now here is given with the probability of the n outcome. This n outcome we are getting 1. Yes, we are knowing that because if n outcome, if we will add all the outcomes, then we will do, then 1 will definitely come. And here the third rule which I had written, that is just equal to the fourth rule. First is just equal to the second rule. How? Because the probability of the omega for the one outcome plus probability of the omega of the two outcome, then 3, 4 and so on to the n number of outcome. And then here we get probability for the sample space. Here this is the sample space. Okay, this is S used for the sample space, because sample space is the set of all the possible outcomes of a random experiment which I had told you earlier also. Okay, so now in the probability part we has discussed each and everything which I had told you over here, and throughout this axiomatic approach to probability comes under the exercise 16.3, and in this exercise you will easily solve if you are knowing each and every formula, or we can say each and every rule, because in this formula is just one, that is number of the favorable outcomes upon the total number of possible outcomes, then we get our result. So in this all the topic which I had told you earlier with the starting of the session or the lecture, there I had told you each and everything which I told you. And for seeing this video, thank you.